Hello, my name is Frank Lanzner. Thank you for watching It's Climate Science. Today we're going to speak about the medieval warm period, but it's a very complicated topic, so I just wanted to mention the measurements of temperature from boreholes. So, first of all, I will go through the basic rough idea, the technique, the methodic behind this. So, this is the Earth crust, a vertical cut. Imagine at one point in time we have a special warming period starting. At some point the upper layers will be warmer, not surprisingly, and if the warming continues long enough, this warming will spread down in the crust. And then at some point, if we imagine that the warming ends, the conditions in the top layer will resume to normal, but still we have all the heat in the ground. Later on, as time goes by, the heat will spread downwards. At the same time, the normal condition will affect more and more area up here. So what is happening over time is that the heat from the warm period will shrink lower and lower and lower down in the crust. And this for me is very fascinating, and scientifically speaking, we can actually, we still have the heat from the medieval warm period and the Roman warm period and all the other warm periods down in the ground. And I like this idea because it makes it less theoretical, more physical. In 1997, Huang and Pollack made an article on this topic, and they examined boreholes worldwide, and here are some of the results. It's the results for the last 1,000 years. You can see three graphs, two blacks and a blue. The blue one is their best estimate, or sort of their average. So it's a blue graph we're going to focus on. In the medieval period, around year 1200 to year 400 and some later, we find in the results the temperatures to be around half a Kelvin warmer than today, and in the Little Ice Age 200 years ago we find temperatures to be almost half a Kelvin colder than today. The finding of a Middle Age warm period and the Little Ice Age is no surprise at all. It's a very common classic pattern in the temperature proxies, and when we at the same time can see that these proxies were taken from 6,000 boreholes worldwide, I have to say this is a very overwhelming piece of evidence. In the article, the authors emphasize that the temperature variations in this type of reconstruction are highly smooth. You see, it's a very soft curve, and the temperature in the ground will always seek to spread, and therefore these data are very smooth, probably one of the most smooth data types we have. So at least 100-year smoothing we can talk about when we talk about boreholes. Further, they write, the results clearly resemble the broad outlines of quaternary climate changes suggested by proxies. And what does that mean? The results clearly resembles what is usually found for temperatures in history by proxies. In other words, when they got these results from 6,000 boreholes, they found exactly what was normally found at the time, 1997. This is only 1 year before Michael Mann made his famous hockey stick in 1998, where there is no longer hardly any medieval warm period and so on. It's a very flat curve. But just 1 year before Michael Mann's hockey stick curve, we have very solid evidence for not only the medieval warm period and the Little Ice Age, but we also have the author's word that on this time this was the consensus. and this is being debated a lot. Also, the writers emphasize that the uppermost 100 meter is the depth range most susceptible to non-climatic perturbations. What does that mean? It means that basically they say the 100 meters, the upper 100 meters of the Earth's crust has many error sources. So data from these layers are not that strong. It means that the newest numbers around year 2000 have issues. Nonetheless, they make their graph until year 2000. I'm not sure exactly how they overcome this problem, but I guess they must have estimated. I'm not clear on that one. So, a decade later, the same people, Huang and Pollack, makes the same kind of analysis, and they get quite a different result. Now, instead of this slope here, from 1800 to year 2000, they have quite a different slope from year 1800 to year 1900 to year 2000. Very different. However, the old data is almost identical. They have changed the last 2 centuries of data, so that the last peak here is now showing more heat, higher temperatures than in the medieval warm period. And how can this be? In the 1997 edition, they write, temperature declined until about 200 years ago, reaching a minimum of about 0.2 to 0.7 Kelvin below present day. About 200 years, there is a minimum below present day. This minimum they are referring to 200 years ago. And they use the word present day. And here they use the word present again. But in their newer article, they explain that this present and present day did not actually mean present and present day at all. They write, the present really represents something like the end of the 19th century rather than the end of the 20th century. And this is the core of the explanation how come they can make such a different graph now suddenly. So bottom line is there's a huge difference between the 2 editions for the last 200 years, and I cannot prove which is correct and which is not. But let's move on to more findings from the Huang and Pollack 2008 article. In the Huang and Pollack article 2008, we can see that for the last few years there is a tremendous peak in temperatures. But now scientifically I have to say something is not quite right. These data are perhaps 100 years smooth, meaning that any peak in real world will not be seen here. It will be compressed down to one line here, so we don't see the peaks in this period. We only see the general average temperature for centuries here. And if you compare that with the peak over 10 years, perhaps with a 5 or 10 years average, you will always get these oscillation or this variation here to be much more dramatic than what is going on here in the 100 year smooth data. So in one graphic, to compare 100 year smooth data in the medieval years with data that is hardly smooth at all, maybe 5 or maximum 10 years smooth, is that science?
It's climate science.
This is the temperature proxy ensemble chosen by Mann 2008 article. And it shows, for example, the instrumental record for the last years with a huge peak here. All data sets here have been 40 years smoothed, Gaussian filter technique or whatever, somehow. And but the instrumental record has not been 40 years smooth. Huang and Pollack has some similarities to the rest of these proxies. They have similarities in the last 200-300 years, so we could call that a fair fit. But the Huang and Pollack 2008 has a development of temperatures here that simply doesn't match all the other temperature data sets. So finally, the main point with this little YouTube video is obviously that the Huang and Pollack data sets is massively different from the rest of the MAN 2008 data sets, and this is important because Huang and Pollack boreholes, and it's not their data sets, it's the pretty much all existing borehole data they have tried to use, 6,000 boreholes. They're measuring on heat in the ground put there in the medieval ages that is still there, so I would call it a very solid piece of evidence. But this evidence obviously does not support the Mann et al. Chosen data sets for the temperatures the last 1,000 years. Many of these data sets use fully or to a large extent tree ring data. Tree ring data have a lot of issues, but let's take that in another YouTube video. Thank you.